Data Science 101. Algorithm away. What and why? There are different data structures in place. What do data scientists do with the data structures? How do they manipulate or access data from these data structures? By means of algorithms. An algorithm is a process or set of rules to be followed in order to achieve a particular goal. They are used to basically optimize processes. Algorithms are around us everywhere. The simplest example of an algorithm is in our kitchens. A recipe or a step-by-step process to prepare a dish is nothing but an algorithm. The internet, email, smartphone apps, video games, all these run on a set of algorithms that instruct them what to do. Why use algorithms? Having a step-by-step process to complete a task makes it easier and more efficient, right? The importance of having this process set comes to fore when it needs to be repeated over time. Algorithms help break down a problem to conceptualizing a clear solution. An algorithm is characterized by its running time, whether in terms of space or time. The term used to describe how fast an algorithm grows is big O. This compares the number of operations within any given algorithm. Here are some runtime terms commonly used. Big omega. This is the best case scenario and describes how quickly an algorithm can run under the best of circumstances. Big O. This is the worst case scenario and describes how slowly a given algorithm will run in the worst case. Big theta. This is used to describe the runtime of an algorithm only if the big omega and the big O are the same. Let's now look at some common algorithms used by data scientists. Linear regression. This algorithm is used to predict the value of the dependent variable using the values of the independent variable. The linear regression model represents the relationship between the input variables x and the output variable y of a dataset in terms of a line given by the equation y is equal to b0 plus b1x, where y is the dependent variable whose value we want to predict. X is the independent variable whose values are used to predicting the dependent variable. b0 and b1 are constant in which b0 is in the y-intercept and b1 is in the slope. Decision trees. Decision trees help in classification and prediction. With decision trees, it becomes easy to understand data to make better predictions. CART, classification and regression algorithm, is one of the most commonly used algorithms to implement decision trees. Here's a diagram to help you understand the CART algorithm. K nearest neighbor. K nearest neighbor considers the complete dataset as a training dataset. K nearest is used to train the model after which the outcome of the new data point is predicted. The KNN algorithm searches the entire dataset to identify the K most similar or nearest neighbor of that data point. It then predicts the outcome based on these K instances. Other commonly used algorithms are listed below. K-means clustering, principal component analysis, neural networks, random forest. That's it about algorithms. Let's now get a brief about visualization.